So with 2.7, it deals with polynomial and rational inequalities. The biggest thing that we'll talk about today are going to be polynomial inequalities, and then we'll hit rational tomorrow. So whenever we have a polynomial inequality, basically you have four things that can happen. Okay? It's either going to be less than or greater than, where things are not included, or it's going to be less than or equal to, or greater than or equal to. Okay. Usually, whenever we talk about, we always talk about our zeros. So basically, whenever it's above the y-axis or below the y-axis. Okay. So whenever we're dealing with that, obviously, if it has that boundary point, okay, or that's what we're dealing with, when is basically is your intercept or your zeros, where everything's either below the x-axis or it is above the x-axis. Okay? If it's including, obviously, then it's going to include that point where it's the equal to, where if it's not, then it's not. It's usually going to be like a dashed line, or that's what you saw whenever you dealt with, especially like quadratics last year. So whenever we deal with a, like in this case, a quadratic, you have the part that is above 0, you have the part that is below 0. So the part that's above 0 is basically in blue, and then the part that is below 0 is in red. Since it has, it's not including those two boundary points of 2 and 5, okay? That's kind of that, that's that threshold that we cross over to where it is 0. So that kind of just gives you that visual that the intercepts in this case kind of serve as those boundary points as far as when it's above, when it's a positive number or when it's a negative number. So whenever we do this, so as far as the procedure to solving anything, it really doesn't change a whole lot from what we've done before. So it's really just a matter of knowing, is it going to be above or below 0? And where those numbers fit in. So the biggest thing is going to be knowing where the boundary points are, if they have a real value. So you solve it just like normal. Okay? Now it says to express the inequality basically where you have it less than 0 and then greater than 0. So then you solve the equation when it's equal to 0. That's going to give you those kind of those 2 points or those multiple points as far as where it's going to cross. Realistically, what's probably going to happen, you're probably going to use a graphing calculator, you're going to type it in, and you're going to go from there and look to see when is it above those zeros, when is it below those zeros. Once you locate those boundary points on the number line, then they're dividing the number line into intervals. Okay? Whenever it crosses that 0, basically it's not an asymptote, but it kind of is, because it's kind of going to section everything off. You're going to go from that negative infinity to that number, then from that number to your next time it crosses, and then so on and so forth until you kind of have those different values, okay, or those kind of different windows if you think about it that way. So what you can use basically, like it says, a representative number or a test value within the interval. Use something that's going to be easy. Like if it crosses between, -1 and 1, or if those are two of your boundary points, what's a smart value to plug in? It's 0. Okay? Find a number that's going to be easy to work with and see, is that if I plug in that value into my function, is it less than 0 or is it greater than 0? Okay? Really, is it positive or is it negative? Okay? And that's going to tell you where it's going to be at. And then you just kind of write your solution set from that value. Okay? Again, realistically, you're going to solve it. What's most likely going to happen, you're going to end up solving it, and then for those of you that have a graphing calculator, you're going to plug it in the graphing calculator and you're going to look. Well, it's above from negative infinity, because we're always dealing with those x values, from negative infinity to whatever you have, and then from whatever that number is to the next interval, and then from that next interval, so on and so forth. So it says solve and graph a solution set on the number line. So the first thing you want to do is move everything over. So x squared minus x is greater than 20. So the first thing that I want to do is I want to move this 20 over to the other side. So if I have x squared minus x minus 20 greater than 0. Okay. Find your boundary points first. Okay. So realistically, if we find our boundary points first, basically all I'm going to do is I'm going to take that x squared minus x minus 20 and I'm going to set it equal to 0. So first off, can I factor this? So there are two numbers that I can multiply together to give me a negative 20 and then combine to give me a negative 1. Yeah, 5 and 4, right? So I can already factor this as far as x minus 5 and x plus 4 and set it equal to 0. So then what are my two boundary points? 5 and negative 4. So in terms of my intervals, okay, I have two boundary points, so that means I'm going to have 3 intervals. Does that make sense? Yes, no, maybe. Okay, I have 3 boundary points. I have 3 times that it's going to cross the x-axis, right? So that means if you have 2 values that it hits the x-axis, then I should have 1 value more than as far as my interval is concerned. Does that make sense? No? If so I have, it's going to cross at negative 4, so right here, and it's going to cross at positive 5. Okay? It's a quadratic, right? So we can, if we're going to graph the quadratic, we have it in standard form. We can go the opposite of b divided by 2a, and if we're going to graph this, right? So it's going to look something like that, right? So there are, let's see if I can draw this a little bit better. Kind of, but not really. Okay, let's just say that it goes through 5. Do you understand now that there are 2 places that it crosses? So that means there is 1, 2, and then 3 that's above, like as far as your interval is concerned. Does that make sense? Like when it's going to be above or below? Okay. So since we have 2 boundary points, okay, then we're going to have 3 intervals in this case. Whereas if it was like to the 3rd power, like if it was a cube, then it would basically change directions 3 times, or it would go 1, 2, and 3. It would cross 3 places, so then we would have 4 intervals, or we should have 4 intervals. Does that make sense? It's not always going to be the case, but that's probably what's going to happen. Okay, just because depending on like if I would have if I have something like that, it can still cross here, right? And I can have multiple values. Does that make sense? Now, kind of as far as what to look for, as far as when it's above or below. So like in this case, so if I've got 3 different intervals, so if we're talking about my value, so from negative infinity to where is it basically above 0? Is f of x bigger than 0? Where's my boundary point here? negative 4. Then from negative 4 to positive 5, where is it? Yeah, so if we put it, it was kind of like arrow, and say that f of x is greater than 0, whereas in that interval, f of x is less than 0, and then from positive 5 to positive infinity, it's going to be back above 0 again. Again, anything with the graphing, remember the graph is kind of secondary here. I just want to make sure you know the biggest thing is like where the interval is. Okay, when is it above, when is it below, and go from there. You'll get everything over to one side and solve for those two values, and you just treat it like a regular quadratic or a cube or whatever you have. I think everything today is going to be a quadratic, so it should be. Now, you may have nothing, so there may be some cases that like, and I'm just going to give you an example, because like, what if it's up here? What if you don't have, what if you don't have any x-intercepts? Then what's our only interval here? Huh? Like if it would be above, like if it's above the x-axis or if it's below the x-axis, like down here, what's our only interval as far as above or below? Like for the one that I drew just right here, what would our interval be? When?
Forever. When it's above.
So what does it mean forever? You're right.
I mean, like, so just.
Right? Makes sense? Okay. Now, I don't think that's how like 2 is, but just so if you see something like that, like if it's always above or if it's always below and it's pointing down, then it's just going to be from negative infinity to positive infinity, it's always positive or it's always negative. Okay? So know that that's kind of a possibility there. So then if we, let's go to the cube here in this last one. So if I have x to the third plus 3x squared is less than or equal to x plus 3. So if we get everything to one side, minus x and minus 3, and it's less than or equal to 0. So this is one of those that you're going to have to basically, you can either plug it in, okay, which I would say most of you would do. Okay, because it's a quadratic, you can try to do it by grouping, which in this case you can do, right? So in this case we can do it by grouping if you want to graph it. So if I group this here, I can group it and say that I have x squared and then x plus 3. So then x plus 3, and I can go negative 1. So then I have x squared minus 1, and x plus 3 is less than or equal to 0. So if we go, can I factor out the x squared minus 1 again? Yep. So as far as my values are concerned, not x squared, but just x plus 1, x minus 1, and then x plus 3 when it's less than or equal to 0. So what are my, if I'm going to deal with my boundary points or my reference points, whatever you want to call those, or my zeros, when is it going to cross the x-axis? What are my zeros? When x is equal to -1, when x is equal to +1, and when x is equal to -3, right? So 1, 2, 3, 4, 1, 2, 3, 4. So then I'm going to have my three values. I'm going to have a value at -3. I'm going to have a value at -1, and then I'm going to have a value at +1. Now, one thing that like we're dealing with, or I'm talking about in my with my Algebra 2 kids right now, because we're going through kind of the same thing. Okay, if it's positive, what is that right side doing? Do you remember those rules? Okay, if it's odd, what happens to like my arrows? You remember? They're opposite of each other, right? Okay, so if they're opposite of each other, that lead number tells you what the right side is doing. So which way is the right side going? Up. Right side's going up. Okay, so if the right side's going up here, then where's the left side going to have to go? Down. So the left side's going down here. Now, again, I'm not real worried about the graph. I'm worried about the interval more than anything. Okay? So as far as in the middle here, what has to happen? Where does this have to go? Well, it has to go above. This one's going to have to go below. And then we go from there. Right? I don't know what it's doing kind of between that -3 and that +1. Not that I don't care, but I'm not real worried about it. You know what I mean? Okay? I just know that in this window here, okay, or in, there we go, okay, like that down here is in red, this is in red, and then here is positive. So what are my windows? Okay, now since it's less than or equal to 0, that means 0 is going to be included with it. Okay, so from -infinity to where? What's my first reference point? -3. It's included, right? Then f of x is less than or equal to 0. What's my next window, or what's my next interval? We got to include -3. So -3 to -1. Then f of x is going to be greater than 0.
Did we not put a bracket around the second 3?
Oh, yes.
So we do put a bracket?
Because it's included.
Okay.
Because since we started here with it as including, or you know, it's including that value, and then we just pick up from there from my -1 to +1. F of x is now less than or equal to 0. And then the last one is going to be from +1 to +infinity, and f of x is greater than or equal to 0.